Hello, welcome. Please have a highlighter. Please be on page 335. We are talking about perpendicular bisector and isosceles triangle theorems. I've identified or highlighted several vocabulary words, and I've gone on ahead and made note cards for these vocabulary words where we'll add examples and definitions and relevant geometry vocabulary that goes with them along the way so that you can use them as hopefully usefully as you are using this giant stack of other vocabulary words like same side interior angles with a diagram on the back. Things like that to really be useful for you. Plus maybe you can partner up and be like, hey, I've got these cards. Let's see if you can guess which word this goes with. Did you know that that's corresponding angles? Did you know that this one is alternate interior angles? Did you know that this one is same side interior angles? Did you know that this one is that was exterior. This is interior. Ooh, missed one. Use your note cards like that. Study off of them. Help them bring the math back up into your brain so you can use it. Let's highlight the learning goals for this lesson. We're going to prove in the next few videos, few pages, that points on a perpendicular bisector, there's a vocabulary word, of a line segment, there's a vocabulary word, are exactly those equidistant, there's a vocabulary word, from the segment's endpoints, there's a vocabulary word. Oh. Is it on the wall? Is it on the wall? Is it on the wall? I don't know. Okay. Ooh, actually, perpendicular and bisect are right next to each other. So that's one for the wall. Okay. Next up, we're going to prove that the base angles of isosceles triangles are congruent. There's a vocabulary word. We're going to demonstrate that 30, 60, 90 degree triangle theorems and the 45, 45, 90 degree triangle theorem using algebraic reasoning. I don't think you know what those theorems are. We're going to learn about them for the first time. You're going to be able to do them. Let's evaluate each expression. Let's jump into this review. All right. Ooh, I need to reset this screen, but we're not moving backwards. We're moving forward. So let's go. Okay. Evaluate each expression. For example, what is going on? Sorry you have to be here to see this. But you're here anyway, and you could always skip the video. You chose this. You chose to watch this video. What's the square root of 25? Would you believe it's 5? We don't talk about the negative ones. It's not a solution to an equation. What's the square root of 9? It's 3. We don't talk about negative 3. It's not the solution to x squared equals 9. What's the square root of 16? It's not the negative 4 because it's not the solution to an equation. It's just the principal simplified square root. What happens if you square a square root? Ooh, zoom in, time. Yes, absolutely. What happens if you square a square root? Well, squaring and square roots cancel each other out. They're opposites of each other. And so the answer of what is the square of the square root of 2? 2. What is the square of the square root of 3? 3. What is, now this one's going to be a little more tricky. Maybe we need to actually do this one with a little bit of caution. Because of the 2 that's out in front of this thing, we're going to rewrite 2 square root 3 twice. Now we write it twice literally because of the square that's out in front of the parentheses. So we've written 2 root 3 and 2 root 3 again. Now if you look at those, we can combine the 2's because we can just make this 2 and this root 3 trade places. It's all gravy under multiplication. So we have 2 times square root 3 times square root 3. 2 times 2 is 4. Square root of 3 times square root of 3 is the same as 3 square roots, square root 3 squared. So highlight for effect. That's a 3, right? Root 3 times root 3 is 3. So this is actually 12. Check it on Desmos if you want to. Shout out Desmos, amazing resource for you for your work. Thank you for watching this video. Please go to page 336 and let's continue your math journey as we talk about perpendicular bisectors and isosceles triangle theorems. Yes. See you in the next video.